computers, internet, and cyber law. You have to know the past to understand the present. Carl Sagan. Part 1. The History of Computers. The computer as we know them today can be traced back to a 19th century English mathematics professor named Charles Babbage. In the 1830s, Babbage designed what he called his analytical engine, which was able to perform arithmetical operations using basic instructions in the form of punched cards, along with a sequential control and a memory unit used to store numbers. It was his design that led to the basic framework of today's computers. First generation computers, 1937 to 1949. In 1937, the first electronic digital computer was built by Dr. John A. Tanisoff and Clifford Berry, and was namely called the A. Tanisoff-Berry computer, or the ABC. Then, in 1943, an electronic computer named Colossus was built for the United States military. Colossus weighed nearly 30 tons and required a staff of 60 people to run. Colossus also needed 18,000 vacuum tubes for processing data, which generated incredible heat, requiring a quarter-acre building for the computer and air conditioning unit needed to allow Colossus to operate efficiently. The computers of this generation could only perform a single task, and they had no operating system. In 1946, the first general-purpose digital computer was built, called the Electronic Numerical Integrator and Computer, or the ENIAC. One of the first assignments given to the ENIAC was a complex problem in nuclear physics that the computer provided the answer to in under 2 hours. It would have taken 100 engineers using conventional methods a year to solve that same problem. When this computer was turned on for the first time, it caused the lights to dim in nearby sections of Philadelphia. In 1949, a new machine, called the Electronic Delay Storage Automatic Calculator, or EDSAC, was built, which added program storage capability and became the first stored program computer in regular use. Second generation computers, 1950 to 1961. This generation of computers replaced bulky vacuum tubes with compact transistors instead, which improved performance and allowed computers to become smaller and less expensive. In 1951, International Business Machine, IBM, built the Universal Automatic Computer, UNIVAC-1, and later the IBM 650 and 700 series. This era of computers used more than 100 computer programming languages. Third generation computers, 1962 to 1971. Computers during this generation used integrated circuits, which combined separate electronic components onto one small silicon disk made from quartz rock. New computers like the Scientific Data Systems Model 810 and the RCA Spectra 7035 all but ended the commercial use of first and second generation computers. By using integrated circuits, computer manufacturers were able to again reduce the size of computers, and they were able to run multiple programs together with a central program controlling the computer memory. Fourth generation computers, 1972 to 1992. The fourth generation of computers began with the development in the 1970s of the Microsoft Disk Operating System, MS-DOS, which was made possible by the invention of the microprocessor, or more commonly known as a CPU. Microprocessor and integrated circuit technology made it possible for computers to fit easily on top of a desk and led to the production of the first laptop computer. One of the first microprocessor computers was the IBM 5150 PC, launched in 1981 and marketed as a personal computer (PC) for home users. The 5150 had its own software, and also allowed third-party software to be used by inserting disks in the open slots of the computer. Microprocessors allowed small startup companies like Apple Computers to introduce a less expensive personal computer called the Apple PC in 1981. 3 years later, Apple introduced a superior PC called the Macintosh, with both models lasting until they were discontinued in early 1993. Fifth generation of computers, 1993 through to the present day. The fifth generation of computers began in the early 1990s as microprocessor companies like Intel developed 32-bit computing with both sound and video processing on one chip. Currently, fifth-generation computers use integrated chips that contain millions of components on a single chip. These computers also use faster parallel processing, where multiple tasks are performed simultaneously versus earlier serial processing of one task at a time. More recent fifth-generation computers use artificial intelligence such as voice recognition that allows the computer to recognize words, allowing it to understand verbal commands and tasks, take dictation, and type words. Part 2, History of the Internet. The modern Internet began during the third generation of computers, when in 1965 Lawrence G. Roberts would perform the first long-distance dial-up connection between a TX2 computer in Massachusetts and a Q32 computer in California. This early Internet technology was further developed in the late 1960s by the Defense Advanced Research Projects Agency, DARPA, that was funded to develop a communication system among government and academic computer research laboratories. The first network component, ARPANET, became operational in October 1969 and consisted of 15 university sites, at which time the U.S. National Science Foundation funded a supplementary network, the Computer Science Network, CSNet. CSNet was finished in 1980 and made available by subscription to academic, government, and industry research labs. During the 1980s, additional networks were added that were able to communicate with one another thanks to the development of the Transmission Control Protocol, TCP, technology, which divides large files into smaller files, or packets, assign sequencing, and address information to each packet, which would reassemble the packets into the original file upon arrival at their final destination. In addition, the Internet Protocol, IP, was developed as a hierarchical addressing system that controls the routing of packets no matter what path is taken before those packets are reassembled upon arrival at their final destination. By 1987, the number of Internet hosts exceeds 20,000, and that same year, Cisco ships its first router. By 1993, the number of websites on the Internet reaches 600, and the White House and United Nations go online, with the number of computers connected growing from 2,000 in 1985 to more than 2 million in 1993. In 1995, Internet service providers like CompuServe, Prodigy, and America Online go live, along with Internet commerce platforms like Amazon.com, eBay, and Craigslist, beginning the Internet's transformation into a global commercial and informational system. 3 years later, in 1998, the Google search engine is born, changing how users explore the Internet. The year 2000 saw MySpace.com introduce a photo and information sharing platform, attracting millions of new Internet users to the era of social networking. Facebook followed soon after in 2004 along with other platform sites like Skype, YouTube.com, Reddit, and Twitter. Today, nearly 60% of the world population has an internet connection. In 1995, it was 16 million internet users, or less than 1%. That user number increased each year, with the first billion reached in 2005, the second billion in 2010, the third billion in 2014, and today there are nearly 4.5 billion internet users throughout the world. Yet, for all its advantages, increased connectivity brings increased risk, and as Americans become more reliant on modern technology, they also become more vulnerable as potential victims to internet crime and cyber attacks. Part 3: Computer and Internet Law, or Cyber Law. Today, the Internet gives worldwide access to a wide range of cyber crimes, including theft, fraud, extortion, as well as human victim crimes like child exploitation and sex trafficking. Law enforcement of our state and federal laws performs an essential role in meeting our nation's cybersecurity objectives relating to national security, as well as safeguarding the privacy interest of America's citizens. The FBI is the lead federal agency for investigating cyber attacks and cyber crimes by criminals, adversaries, and terrorists. The threat is serious and intrusions are becoming more commonplace, more dangerous, and more sophisticated. Some attacks take down vital systems, disrupting and sometimes disabling the work of hospitals, banks, and 911 centers around the country. The Department of Homeland Security, DHS, works with other federal agencies to disrupt and defeat cyber criminals, prioritize the recruitment and training of technical experts, develop standardized methods, and broadly share cyber response practices and tools. Rules and regulations of the Internet. Countries rely on their own legislation to mold behavior and manage policy. Lawrence Lessig, a preeminent expert on Internet law, understood this and wrote extensively concerning Internet law, also known as cyberspace law, and how that is the first aspect that regulates behavior in cyberspace, saying, "Legislatures enact, prosecutors threaten, and courts convict." Internet law and computer law. The expanse and complexity of the Internet and all of its potential liabilities. Today's attorney must understand not only the law, but how legal principles and applicable laws govern the use of the Internet, as there is a great amount of uncertainty regarding what is permitted under Internet law. Unlike other areas of the law, Internet law cannot be identified as one solid, stable, and specific field of practice. Rather, it incorporates and applies principles from several traditional fields that predate the Internet. Since the Internet is relatively new and constantly evolving, laws surrounding its use cannot be informed solely by precedent or common law. Adding to the Internet's complexity is the realization that it cannot be bound by the laws of any one nation's government. There are many legal challenges in Internet and computer law today, and those challenges will only be greater in the future. Only by learning, training, and understanding cyber law can judges, prosecutors, civil attorneys, and criminal defense lawyers be fully prepared to meet the cyber challenge that now reaches into virtually every aspect of the law. The end.